Hi, I'm Hassan, and my entry for this hackathon is called Codomain, which is a platform to use LLMs to help build supervised training datasets faster and cheaper. So, despite lots of advances in few shot and zero shot models, supervised models are still, they form the majority of most deployed models in production. And a lot of these supervised models require substantial amounts of data, and so this need for labeled data has allowed companies like Scale AI to exist, which is now worth billions. It's still quite expensive to collect this labeled data set for your task and time consuming. And then even once you've built your first training data set, there's an ongoing effort to collect more data to improve on your model's weaknesses and drifting data distribution, which always happens. I've been doing this for like 5 years in NLP. So I've gained quite a good understanding of this problem. So this is where my hackathon project Codomain comes in, which I'll repeat uses LLMs to help build supervised training datasets faster and cheaper. Using the project, you can generate completely new training examples, as well as create labels for your unlabeled examples. So if we think about human labels as gold standard labels, this is sort of like silver standard labels, which you can then train on. So moving on to the actual app, you start off here on the load page where you need to upload 3 files. Some information about the company/project, some information about the labels which are present in your data, and finally the data itself. So inside the company CSV, it's literally just 2 things: name of the company/product and description of the company/product. So the data we've uploaded is actually text queries that a banking app has received. So in terms of the company, we've gone for Revolut, and the description is something like Revolut is a digital banking app which has no branches. So let's explore the data here. So in terms of the data we uploaded, it's just 4 columns. The first is the text of the query. The second is the label. So this first row is a labeled example, but the second row has no label. So that's an unlabeled example. And we also have 2 indicators of whether this example was generated using natural language generation, or whether this label for this example was generated using LLMs. On the left-hand side, we also have some summary information, such as how many rows we have, how many of them are unlabeled, how many rows are generated, and how many labels are generated, as well as how many labels are there in total. So moving on to the actual labels data that we uploaded, that's, as you can see here, it's just the name of the label in plain English and then the description. So for example, activate my card, the description is something like query referring to activating their card. Quite simple. We also have an examples column, which is blank here because we can actually use the examples available in the data. And we also have the count here on the right hand side. So let's move on to the actual magic now. So you might see that the final label exchanged via app has around 20 to 50 less than all the other ones. So this is a slight imbalance, and someone working on this might want to solve that imbalance. So what we can do is we can actually generate some examples for that final label. So let's do that. And you'll see here on the left-hand side that these summary stats will change. So now we have 791 labeled data, and 10 of those are generated, which is the ones we just produced. So let's take a closer look at that in the data tab, and we can sort here to put them right at the top. Okay, so these are the 10 we've just generated, which all seem to be good. Another use case is, for example, we have 186 unlabeled examples. Let's produce that number. So we can actually generate labels for examples. This is actually like pseudo annotation. So let's do that. And that's running in the background. And you'll see that this number is now dropped by 10. We've just labeled 10 examples. So let's take a closer look. In this case, they would be these top 10 here because these 10 rows existed in the data. So they aren't generated, but their labels are generated. So these are the ones we just labeled. And do they look right? Exchange via app. Balance not updated after transfer. Why wasn't my bank balance updated? Activation, cash withdrawal. They seem to be correct. Pretty good for silver standard data. Now, finally, one other use case is, let's assume this banking app wants to introduce something new, but they don't have enough data to capture it just yet. Or in fact, they might have no data to capture it, but they know that they want to track this from the get-go. So they can actually add a label. So if we add this particular label where we want to track changing of card PIN. So if I just fill this out, the description of this would be query referring to changing card PIN number. And because there's no examples in the data, we should actually include some examples. So this should actually say examples. I'll change that. So we've now added that. This has been bumped up by 1. So there's now 6 labels and that's been added here at the bottom. Now we have 0 of these examples. And if we want to train a model, we need to have about 100 of them, right? So this is another piece of magic that can be done here. We can generate examples. Previously, we've done it for an existing label. Now we're going to do it for a new label where we have no existing data. So let's try that out. Let's generate 10 examples. Right. So we now have 801 rows of data. So let's take a closer look. So in this case, we added this change card PIN. So these are the 10 examples we've just generated out of thin air for a label which didn't exist in the data at all. And let's take a closer look at them. How do I change my PIN? I forgot my Revolut PIN. How can I reset it? Is it possible to change my Revolut card PIN to a custom one? They all seem quite correct. So those are 3 very, very valid use cases. I've definitely needed those in the past at some point. And finally, you know, the person, the data scientist working on this model can download the data and the new labels, which they can at some point, you know, down the development path, upload again and work on them again, and they preserve all of the metadata around what was generated, what wasn't generated, because it's very important to keep a track on that. So thank you for listening, and this is my hackathon project.